previous video lecture we have discussed the random variable, different types of random variable, discrete random variable and continuous random variable. From the discrete random variable we will obtain the quantity mass function PMF, and from the continuous random variable we will obtain the quantity density function. Three types of quantity mass function is here: binomial, Bernoulli and Poisson distribution. For three types of PDF is here: exponential distribution, normal distribution and standard normal distribution. And what is the random variable? We have discussed the random variable is a function from sample space to real number. Suppose x is a random variable. X is a random variable is here is such that sample space to real number. This function is also called the measurable function. It is also discussed the previous video lecture. Suppose x is a random variable, c is a constant belongs to R. Then we can say that the c of x is also random variable RV. So another random variable y is also random variable is 2R. Then we can say that x plus y is also random variable, x minus y is also random variable, x into or product of two random variable is also the random variable. Suppose x is a random variable, sample space to real number, the mod x is also the RV, random variable. Summation of two random variable, it's also random variable. Summation, subtraction, multiplication and modulus is also random variable. See any constant, the c of x is also random variable of c of x is also random variable. Why the random variable? The summation, subtraction, multiplication and modulus of x is also random variable of any random variable. See, two types random variable. Previously we have discussed the discrete type, when the random variable are the finite number or countably infinite. These types of random variables say that the discrete type, and continuous type is within limit or interval. Suppose x belongs to 1 to 2. This is also random. The value of a random variable, it is called the continuous random variable within the interval. Limit of small x tends to infinity. It's types of this. Suppose f of x. These types of random variable is also called the continuous types of random variable. We have discussed the quantity mass function PMA satisfies the two conditions. First condition is that all fx greater than equal to 0. Second condition, summation of fx equal to 1. It is for the discrete case. Discrete case are continuous. For the continuous case, first case is same. For first case, the all summation of fx greater than equal to 0 for all x, and integration fx dx equal to 1 for all x. When this this function is said that quantity density function PDF. First case the quantity mass function. First case is the same for the both case, and second condition is the summation, and quantity mass function and quantity density function case is the integration. And we have also discussed the different types of question, whether it is the PMF or not. For the PMF or not means we check the first condition and also check the second condition. First condition, all fx greater than equal to 0 for all x, and summation f of x equal to 1 or not. If each two condition is satisfied, then we say that it is the quantity mass function. Second condition is here. For the second condition, say for the case of the constant, k, then we also check that only summation of f of x equal to 1 for here to also obtain the k value. Or case for the quantity density function PDF case is here. For the PDF case, first we check that all f of x greater than equal to 0 or not. Second condition, integration fx dx equal to 1 or not. If it is two conditions satisfied, then we can say that from here you obtain PDF quantity density function. And last one is for the last one, to find the value of k. For the value of k, then we calculate the integration fx dx equal to 1. For this formula, we also calculate the integration value. Suppose for the case of this, our value is the 1 to 2. For value is the 1 to 2 means we calculate indicate here. We also indicate here integration 1 to 2 fx dx is here. Then we calculate the k value. In the last previous class, we also details we will discuss the in the this 4 question, and next question we also calculate the discrete type for the mass function. We add this. This means the this p of x means the this p of capital X equal to, it is also equal to f of x. Okay, that means we also add all p capital X equal to small x equal to 1 to obtain the k value. That means we add the 0 plus k plus 2k plus 3k plus 3k plus 4k plus 5k plus 6k equal to 1. We obtain the value of k. The second question, same second question, you also check the 0. For the second question 0 0.1, 0 0.3, 0 0.4 and plus k equal to 1. 0. For the question 0 0.1, 0 0.3, 0 0.1 plus 0 0.3 plus 0 0.4 plus k equal to 1. We obtain the k value, k equal to 1 minus 0 0.1 plus 0 0.3 plus 0 0.4. 7, 8 means 0. Your answer 0 0.2. This is the value of the k. The in the p of capital X less than 5 means the we obtain the up to 5 means 0 0.1 plus 0 0.3, less than 5 means we obtain 0 0.4 value. Now today we will discuss the density function, or it is also called the cumulative density function. Also called the cumulative distribution function. Density function is called the Dept, or it is also called the CDF. A function capital X is said to be CDF when probability value of random variable x less than equal to small x. It is the definition of the CDF or Dept. A function is said to be capital Fx function is said to be cumulative distribution function when probability value of random variable capital X less than equal to small x. That is the, here is also right here. Here is also right the value capital A f of, also right here f of suffix of x random variable x small x equal to the capital P of capital X less than equal to small x. This is the definition of the random. This is the definition of the cumulative distribution function. For the random variable is the definition is the sample space to real number. This is the capital X. This is the real number R. This is the sample space to real number. This is the capital X. Capital X such that small x to capital R. It is the definition of the RV. For the definition of RV and definition of the next we discuss the definition of, here we discuss the CDF. Here we discuss the CDF equal to the function such that random real number to the value 0, 1. Here domain set S, codomain says the real number, the all value for the random number, all value takes for sample space, and here the CDF case the capital Fx equal to capital Fx suffix of x equal to P of capital X less than equal to small x. Here all value takes from the real number to the value smaller value, obtain the value of small 0 and 1. That means the f of lower value the 0 and upper value is the 1. The if f belongs to f, that is the value of lower value of 1. It is the same also you can remember any positive value of obtain the any positive value of 0 less equal to P of A, any even A less than equal to 1. Any even of positive value belongs to 0 to 1. Same also remember the CDF value is also the belongs to 0 to 1. Here also note the capital F. Here capital F equal to note 1. Capital F belongs to real number to 0 to 1. Lower value 0. The limiting case x tends to minus infinity, and that's value is the 0, and x tends to infinity, value is the 1. That means you can draw the figure. If this is the real line, minus infinity to infinity, where minus infinity the fx value is the 0 and upper value is the infinity, value is the 1. And for the continuous case, fx equal to, for the, we know the two types of random variable, under the continuous and another the discrete. For continuous case, we obtain capital fx suffix of x equal to the formula of this integration minus infinity to x f of x dx. And discrete case, capital fx has the capital fx suffix x equal to small x equal to summation of f of x, where less than equal to small x. The two type definition, the discrete continuous type and discrete type. For continuous type, the CDF of the random variable capital X equal to integration minus infinity to upper limit or the limit the small x to fx dx. We also write capital f of x equal to small x equal to minus infinity to t ft dt. It is also same for the t variable is here. The lower value, upper value always remember the x or t, that this is the d of dt or d of x is equal to x. For the case of also write t form. For the discrete case, f of x equal to small x equal to suffix capital X small x equal to integration f of t less than equal to small x. The t value up to less than equal to small x. Here also write the continuous case in t value minus integration to t ft dt or summation t less than equal to x ft. For the continuous case, this formula is obvious. For continuous case, for the continuous case, f of b minus f of a means the integration f of b minus f of a equal to integration a to b fx dx. The both integration case is the equal when x lower limit close and upper limit both are the close interval. This is also in probability value a less than equal to x less than b, and when this is the close and this is the a close and b open, this is also the equal. You also write here the integration a to b integration a to b a for x dx equal to p of value that means the integration a to b fx dx equal to f of upper limit minus f of lower limit. When you can use the capital F, that means that it is the CDF. When you use the small f, that's the PDF. What is density function? Because the range is the continuous. When you use the capital F, that is the, you can remember the CDF, cumulative distribution function. When in the both case, that means the both case the P of a less than equal to x less than b, it is also equal same. Quality of a less than x less equal to b, it is also equal. Or p of a less than x less than b, it is also equal to that interaction. Or p of a less than equal to x less than b, it is also both are equal to f of b minus f of a. Here you also write here the all are the equal to integration is the integration a to b fx dx equal to quality value a less than equal to x less than b, p of a less equal to x less than b, all are the equal. And next is they discuss the f of small, how to obtain the small fx. Small fx in the PDF, that means the derivative of f of x by d of x. Here you also write, here you can write the fx, capital F of surface x equal to, for the continuous case, continuous case, that means integration minus infinity to x fx dx, and we also obtain when the fx is here, fx given, when also here capital F is given, when capital F of x given, then small f of x we can obtain derivative of capital X by d of x. We can also write suffix of x, or suffix of x we also write here. That means you remember, for the continuous case, capital A we obtain when the small fx is given, when the capital fx is given, then we can require for the derivatives for the PDF. This is the CDF. Also write here, this is right here, and we also suggest the question. F is the continuous random variable having the point density function PDF, small fx equal to x square by 3, the range is here, open interval here, minus 1, 2 and 0 anywhere. To first verify the fx the PDF or not. This is a continuous case, means for the continuous case we obtain the PDF, check that it is PDF or not, and also find the cumulative distribution function CDF. Also find the question is here, find the positive value 0 less than x and less than 0 less than x and less than 1, less than equal to 1. Now we solve the here is here question number 1. Fx is given, fx means that this fx equal to quantity density function equal to integration, this here question is here, question fx equal to x square by 3 and 0, x square by 3, 0 less than, or the interval minus 1 less than x less than 2, minus 1 less than x less than 2 and 0 anywhere but elsewhere. Where first we check it, first question is the check what it is the first question, it is PDF or not. Second question, find the value of capital A cumulative distribution function and the value. Okay, now verify that, first verify PDF or not. For the case of PDF we already discussed here. For the case for the PDF, the integration fx, for the case for the PDF they also integrate the fx dx equal to 1 to obtain the value of the, it is satisfied, then you say that it is the quadratic density function. Now we check the integrate. Integration minus 1 to 2, both are open or closed, both are in the quadratic case, the continuous case both are equal. The f of dx, we check this value is 1 or not. Okay, now we obtain the, put the value to the value minus 1 to 2 x square by 3 dx. Okay, minus 1 to 3 x square by 3 dx equal to 1 by 3 x cube by 3, the value minus 1 to 2. We also calculate 1 by 9 x cube minus 1 to 2, that means 1 by 9 2 cube by 8 minus of minus 1, that means 9 by 9 equal to 1. So first case we check all, we put the any value, the square is here. First case we can put any value, first we check any value of all fx greater than equal to 0 for interval minus 1 less than x less than 2, because of square term is here, square term is here, so x square means here all are the positive value. So first case the definition of the PDF is satisfied. Second case the integrated value fx dx equal to 1. So the given question the fx, so therefore given fx is pda quadratic density function. First is satisfied. Second question. First is satisfied. Go to the second question. Second question is to find the f of x. For the second question, to find capital F of x. Okay, capital F of x means the cumulative distribution function. What is the range? Remember the range minus infinity to infinity. Then starting the minus 1 to 2. So the case 1 is the means the minus infinity less than small x less than minus 1, so less than equal to minus 1. We choose this area. Okay, so here in case what is the value of capital of fx equal to minus infinity to x fx dx. This is the definition of the cumulative distribution function. You can write suffix x, it doesn't matter. So you can write here minus infinity to x. What is the value is here? This value is the 0 of dx. What is the value? fx value? fx value only for the value, only write the value minus 1 to 2. So here value is the fx is 0. So indicate here you can value obtain the value 0. Next case 2. We can divide the 3 interval. 1, this is the 1 interval. Case 1, this is the case 2, and this is the case 3. So the case 2 for the interval, for the case 2 interval, this is the interval for case 2. Case 2 interval is the minus 1 less than x less than 2. Okay, minus 1 less than x. The always remember that the upper limit always the x. So capital fx of x equal to capital F of x equal to minus infinity to x fx dx equal minus infinity to x. This is the definition, and you can also write the here break minus infinity to minus 1 fx dx plus minus 1 to x fx dx. Okay, because of we also this is the your this is the previous interval is here, this types of interval minus infinity to infinity and minus 1 to 2. We also start from minus infinity. The minus infinity to 1 first we write here, and second write the minus 1 to x. Always remember that upper limit always the x. So minus 1 to x, not 2. Upper limit, if it is write 2, it is the value, the constant value. So always write the upper value is the 2. So we also obtain the here is also obtain the minus infinity to minus 1, this value 0 dx plus minus 1 to x. What is the value? X square by 3 dx. The value is given. The value is given given the question. Fx value is given only for the minus 1 to 2. Okay. So here we also write calculate the value. So we also calculate here the first the 0 plus 1 by 9 x cube minus 1 to x. So 1 by 9 x cube plus 1. This is your answer. What is the answer? You can solve the interval minus 1 less than x less than 2. Next part. Next part, case 3. What is the next part? Go to the interval minus infinity to infinity minus 1 to 2. This is already happened. This value is 0. This is already happened. This value 1 by 9 x cube plus 1. Last part is here. Last part is the 2 to infinity. F of x equal to starting the definition is the same, minus infinity to x fx dx, but next we write the all the interval case minus infinity to x, minus infinity to now in minus infinity to minus 1. First start this interval fx dx plus minus 1 to 2 fx dx plus 2 to x fx dx. When the case for the 2, we all are start from the, remember, all the start from capital F minus infinitive, and last is the fx. For the previous case, we also obtain start from the minus infinity to minus 1 to x. For the 3 part, minus 1 to 1, minus 1 to 2 to x. Okay, we also divide this because of this the interval from start from here. First we write it here, second also write here, or next also write here. Where you can start, then you can start the, remember this is the minimum lower value, upper value is the x. This is the upper value, lower value to upper value. Now also calculate. First part, integration minus infinity to minus 1 0 plus minus infinity to 2 value is the minus infinity to value is the x square by 3 dx plus here value is the 2 to x value 0 d of x. Okay. Now for the case is here the value 1 by this value 0, 1 by 3 x cube by 3 minus 1 to 2. So you obtain 1 by 9 and 2 cube minus plus 1. This means this value 1 by 9 into 9, so it is 1. We obtain the 3 value for the 3 interval. So now write down the capital F of x, surface of x, this equal to the small x, but this equal to start from the minus infinity starting value, minus infinity less than x less than equal to minus 1. This value is the 0 from the first one. So first one very good. First one is obtain this value 0 value. Next second, for the second value minus second case, for the second case this is the interval. What is the value? Value is the this is the value 1 by 9 x cube plus 1. 1 by 9 x cube. So right here 1 by 9 x cube plus 1 interval minus 1 less than x less than 2, and last one the value is the 1. When the value 2 less than x less than infinity, last value you obtain, last value is the 1. What is the interval? Interval is the what is the case or interval? Interval is the minus 2 less than x less than infinity. Okay. So this is your given answer is the first the 0 case minus infinity to minus 1, this value, this is the lower value is the 0 and upper value is the 1. And go to the last, what is the last question? Last question, the positive value x or the last question, positive value p of 0 less than capital X less equal to 1. Find the value of p 0 less than capital X less equal to 1. Now we check it. 0 less than x less than equal to 1. What is the definition? Definition is direct. We also obtain f of 1 minus f of 0. Direct we also calculate is here f of 1 minus f of, so we know that p of a less than x less equal to b. What is the formula? b of b minus f of a. We put the direct value. Direct we can also put here direct value. Direct value, this is form is here also direct value of this equal to f of 1 means we put the value is here. Minus 1 is direct meaning the open interval. We put the value 1 by 9 plus 1 cube. 1 cube plus 1 for the f of 1 minus f of 0. Put the value x equal to 0. 1 by 9 0 plus 1. So your option here, we also calculate here 1 plus 1, 2 by 9 minus 1 by 9. So the value is the value 1 by 9. The positive value you obtain is your answer. Also obtain is value is the positive value 0 less than x less than equal to 1, value is the 1 by 9. Similarly, also calculate the next question, question number 2. Calculate the direct p of x equal x less than means what is the meaning of this? This means p of minus infinity less than, sorry, this mean what is the meaning of this? Meaning of this, what is the meaning of this? This means the p of 1 by 2 less than capital X less than infinity. It means that lower value minus in 1 by 2 up to upper value is, we can use the direct formula f of infinity minus f of 1 by 2. So we also calculate what is the capital F. Then we put the value, what is the f of infinity value? F of infinity value 1 minus f of 1 by 2. Put the value, calculate the f of x and put the value 1 by 2. That means the f of 1 by 2. So 1 minus that's the value 1 minus this 1 minus f of b f of 1 by 2. Similarly, we also calculate the question number 3, the point density function random variable x, f of x equal to f of x equal to f of x equal to kappa, f of x equal to kappa into x minus 1, 2 minus x. The interval 1 less than equal to x less than equal to, it's very important question, West Bengal University Technology. And we also value of the k value integration 1 to 2 kappa into x minus 1 x minus 2 dx equal to 1. We also calculate the value of k. And also k, you can use the formula. You know the f of 3 by 2 minus f of 5 by 4. This is the question number 3. Next we come the question, the quantity mass function. In the previous 3 questions are the quantity density function. Now this is in the 3 question PDF and now the PMF. How to calculate the quantity density cumulative distribution function for the quantity mass function. The question is here, find the distribution function CDF from the body mass function. If x is given or small fx is also small fx equal to means the body mass function. You can also check from the table. You can add all the table, all the value. This also equal to 1. We also know the integral summation f of x equal to 1. We can put the value. We add the value minus. We add the value 0.25 plus 0.5 plus 0.25 is equal to 1. So this question is okay for the quantity mass function. Now we calculate the f of x. What is the f of x? F of x is the cumulative distribution function. Starting value, we know the interval. What the interval? Minus infinity to infinity. Okay. So what the value? Value 0 point is here, 1 point is here, 2 point is here. This is the 0 point. This is the 1 point. This is the 2 point. So first starting from the minus infinity to 0, this value 0. But table is no value is given. Okay. Next 0 to 1. Next interval, we can write the continuous way 0 to 1. What is the value? Value is given 0.25. Second interval, second is value 0.25. Second is interval 1 to 2. So 1 to 2 value we know the f of capital X equal to summation of f of t less than equal to small x. So up to value 1, so 0.25 plus 0.5, starting 0.0 for the case 0 plus 1, 0.25, 25 plus 0.5 for the case for the 1. The value less equal up to start from the value minus b start from the value up to x. Second, last one the 2 to infinity, 2 to infinity in this area. We also calculate the CDF for the in this area. All the value 0 point case the all the value means here is here 0.25 first value for the case of 0, that means the f of 0 plus f of 1 plus f of 2 for the case of the 2 less equal to x less than infinity. So value is the equal, check that it is also 1. Lower value the 0, upper value was. We also check the continuous case we also obtain. For the continuous case we also obtain is here. Also obtain is here. Lower value 0 and upper value 1. Similar way for the discrete case. For the discrete case the lower value is the 0 and upper value is the 1. In the same way, also calculate the second question. This question you also calculate the what is the value. Suppose you question the all value 1 by 6. So you can write here capital f of x equal to integration minus infinity less than x less than 1. What is the minus into less than x less than 1? What is the value? 0. First value no value is table is given is here 0. Second 1 by 6, 1 less equal to x less than 2. Second and next 1 by 6 plus 1 by 6, 2 less equal to x less than 3. 1 by 6 plus 1 by 6 plus 1 by 6 equal to 3 less equal to x less than 4. And same way also calculate the last. Same way calculate the 1 for the last value in the question 6. Last value when there is 6 less equal to or less x less than infinity. This way also calculate the CDF from the probability mass function. We also calculate the same way for the value constant value of k. That means we add the all term of fx. Then we know that p of capital X equal to small x equal to 1. We obtain the value of k. Here the k square is here means 2 values obtained. What is the satisfied? Then you can check. And next p of capital X greater than equal to 6 means p of capital X equal to 6 plus p of capital X equal to 7. That is the two value starting value 6 to up to x. Here is x equal to up to 7 and p of in the discrete case we also calculate the p of 3 less than capital X less equal to 6 means 3 less than p of 3 less than capital X less equal to 6 means start from the x equal to 4. 3 is not equal. For the continuous case you can check that which is equal or not equal. For discrete case is also check is the equal or not equal. For continuous is the both are equal. Less than or equal case the both are equal. Check the p of x equal to 5 plus p of x equal to 6. That's the value is given. P of x equal to 6 x equal to so check p of x equal to 4 means p of x equal to 4 means 3 of k. You can write here. You can write p of x equal to 4 means 3 of k plus something plus this. P of x equal to 5 means x equal to 5 k square. K square you can put the value k and value up next we got the value of 6. 6 means 2k square means 2k square. We also value I think here is value k equal to minus 9 by 10. So put the value 3. Positive k is the real number, so it does not matter whether positive or negative. Positive value always remember that it is a positive value, not negative. because any value of probability, even P of A less equal to 1, probability value, but this is a constant, belongs to any constant, belongs to real number. It doesn't matter number is positive or negative. So 3 into minus 9 by 10 plus minus 9 by 10 square plus 2 into minus 9 by 10, so 3k square, it is the 3k square, sorry, it's okay, it's 3k. We also obtain the value of this is always value, either you obtain the positive value. So go to the here, we also calculate the what is the minimum value, we also calculate what is the next question, what is the calculate of the, we also calculate the minimum value, which value, for the which value it is the satisfied that the minimum value of x, the P of capital X less than equal to small x greater than 6, 1 by 2, 0.5 greater than value of the 6. Okay, find the value for the which value of x, the positive value just 0.5 greater value. Okay, next class we will discuss the what is the mean, variance and standard deviation. Mainly two types. Positive mean of data, there is the summation of all xi by total number of data, or mean of positive distribution. Next class we will discuss the mean two types also, the random variable two types, discrete type and continuous type. So mean also two types, mean of discrete distribution, mean of continuous distribution. Next class we will also discuss this way, the what is the mean of positive. Thank you.